class. I wanted to put the last bit of our lecture today online since it went over time, and some of you may have not been there for the last bit of our discussion. And so where we left it at around 11:30 was that we had come to the realization that there is lots of data that does not support the hypothesis that the differences in mathematical aptitude between males and females is exclusively due to biological differences. So we found lots of data that did not support that hypothesis. Right? We saw lots of data, and in fact, the contrary seems to be the case, where when social, cultural factors are accounted for, when we look at change over time, we see that in fact the difference in mathematical aptitude seems to disappear. And there's a number of cultural, societal factors that seem to influence that difference when we do see it. Albeit, this is still all in the context of a very small to negligible difference. So, pose this question again, looking at this data here from the Pew Research Center. That shows that, well, if we come to the conclusion that there is no biological, no to very little biological reason why males and females will have different, show different aptitudes in math, and in fact, it's in contemporary times, it's most of the time it's not even measurable anymore. It just doesn't exist. So why are women still unrepresented in math-heavy STEM fields? So still, in things like computer science and engineering, there's a real dearth of positions that are held by females. And so why is this? So certainly things like sex or gender discrimination in hiring practices. I think this was mentioned early in our discussion about biases in hiring. There's also been hypotheses put forward that there is a difference in general interest, that interest has correlates with the two genders, male and female. And so perhaps this might explain some of it. And so we discussed this interesting hypothesis. Well, first, let me share this bit of data too. This is from the cross-national patterns study that we talked about. So that study that looked at 69 different nations, different countries, to see if this this bias, this sex bias in mathematical ability, if there are any patterns. And we did see some patterns, right? That typically the effect size shrinks or becomes zero in countries where educational opportunities are the same for boys and girls, as an example. And this was another thing that study found. In nations with greater gender equity, gender differences in valuing math, extrinsic and intrinsic motivation, self-concept, and self-efficacy were larger. So to put it very mildly, the view of how the two sexes, how they view mathematics, the value they attach to it, how much motivation they have in pursuing mathematics. There's a greater gender bias in countries that have a greater gender equity and equality. This has been termed there we go. There's no good place to put me. The gender equality paradox in STEM. And so let's take a look at the data. at the graphs. So as we discussed in class, we looked at these two scatter plots. So first let's orient ourselves with what the axes mean. So the y-axes for both are this global gender gap index. And it's a metric that is a composite, it's a score based on a composite of different measurements that have to do with gender equality. So within there, it's composed of things like what is the gender gap in pay for the same job. So in Norway, for example, male and females make relatively the same amount of money for the same position compared to the United States, and even more so for other countries like Turkey, for example. So this global gender gap index is based on a composite of a bunch of different things. And that was just one example of what gets plugged into that. And so you get this one score, this one number, this one metric that tells you relatively how equal genders are within that country. So the higher the number, presumably the higher the gender equality and the gender equity. And the lower number, the less. So for this first graph, we see that the gender gap in individual science performance. And again, we're looking at an effect size. And if you remember, because of the way they code these things in data, it's always the males minus the females. So if males outperform in here in individual science performance, if males are outperforming, it'll be a positive number. And so that's what we see here for the vast majority of countries, except for Lebanon, apparently. The vast majority of countries are positive in that effect size. So that means that males are outperforming females on in science performance. And these are typically tend to be these standardized tests. And we see that there's a general trend here, albeit there's quite a bit of noise, right? It's kind of a blob, but a general trend that the greater, well, I should put it this way, that the higher the gender equality in a nation tends to have an even greater sex bias discrepancy in science performance. So you can see Norway here. It's got the highest difference in comparing female to male performance in science. About 0.85. Though they are one of the highest in terms of gender equality, which seems to be a paradox. You would think it would be the other way around, that as countries increase their gender equality, that difference that you see would grow smaller and smaller if these differences in mathematical abilities and more generally here science are due to social cultural factors. We see a similar pattern when we take a look at the percent women among STEM graduates. So individuals that are getting degrees in science, technology, engineering, and math. It turns out that there's an even stronger relationship. It's more of a linear line here compared to this, which is kind of like a big glob right here in the middle. There's a fairly strong relationship between the degree of gender equality and how many women, what percent women are getting degrees in the STEM fields. And on average, the lower your country's gender equality, the higher percent of your STEM degrees are awarded to women, which again is that paradox, kind of the opposite of what you would expect. So what could be going on here? Well, one hypothesis has to do with this bias in reading ability. So we talked a lot, mostly in class, about mathematical aptitude. On the other side of the coin is the observation that girls and women tend to score higher in reading ability and language scores. And what's interesting about this relationship is that typically when on the individual level, individuals that score higher in math competency also score higher in reading competency, right? Sort of this idea that, like, well, if you're smart, you're kind of just like smart, everywhere. If you did bad on the SATs, you're more likely to have done bad on both the math and the language portion. And, for the person in the class that's like the valedictorian, they probably got stellar SAT scores on both. And so this is a general trend overall, that individuals that tend to score higher in one area of cognitive ability also tend to score higher in another. But the thing is that correlation of those two things tracking as your math ability goes up, your reading ability goes up. Those lines aren't parallel for girls and women. So what happens is that when you look across individuals within a population and you look at scores, women or girls that tend to do better in math competency do even greater in reading and language abilities. So trying to think of a good example to illustrate this. You can think of it as, if we really simplify it, and everyone gets tested on this very simple standardized test, and you get a score of 1 to 10, and we see that, say for boys, the average is 5 for math, and the average for reading is also 5. And they see a pattern that typically for most boys, if they score 6, or they score 7, or they score an 8 in math, they also see what tends to happen is that reading, they tend to score a 7, or a 6, a 7, or an 8. It tracks. Right? So they'll score a 6 in math and a 6 in reading, or 7 in math and a 7 in reading. Or the really smart boys will get a 9 in math and a 9 in reading. But they find that when the math ability goes up for girls, when you look at girls and you say, like, okay, well, let's look at the ones that scored 5, and the ones that scored 6, and then the ones that scored 7. Do we see a similar pattern? Do we see that their reading goes from 5 to 6 to 7? No. What they see that it increases more rapidly. So from 5 to 6 in math, the girls may go from 5 to 7. And then another jump in math from 6 to 7, the girls are all of a sudden up at 10. Their reading abilities track much quicker. They increase much faster than the math abilities. And so this paper that came out in one of the premier biological journals, or actually this is multidiscipline. Girls' comparative advantage in reading can largely explain the gender gap in math-related fields. So the gender gap in math-related fields, right? That's essentially, why do we have 85% of our engineers are male? And you can think about it in the other way. Why are over 90% of our speech pathologists female? That is what I mean when I say gender gap in a field. And those are both math-related fields. So let's take a look at the data that they collected here for boys and girls. They measured their math ability, and they also measured their intentions to study math going forward. And so we can see that the boys here in red, it might not be a surprise that the better they did in math, 10 is the top 10% percentile. 10 would be 90 and over percentile, so that means that 90% of everyone else scored less than you. So this is our highest scoring individuals and our lowest. So you can see as you score higher on these math ability tests, those individuals tend to want to pursue math going forward, which makes sense. Most people kind of like to do the things that they're good at. And it makes sense that you're good at something, you want to pursue it. And there's like a great example of this is I really like board games. My wife really likes to win at things. My wife typically doesn't win at board games. So my wife doesn't like board games. So, and anecdotally, you might have the same experience. The things that you're not good at, do you pursue those things? So this isn't that much of a surprise. The better the students were at math, the more likely that they had the motivation and the value and the intention to pursue it going forward. They also compared how they did, what their reading scores were like going forward, or what their reading ability was, and then their intentions to study math going forward. And so let's take a look and let's think about this. If your reading ability goes up and tracks with your math ability, you would expect a similar relationship. Because your math ability is going up, then your reading ability is going to go up too, just because of that general, if you're smarter, you're kind of smarter and everything. Then we should see a similar pattern as we see over here. So that's true somewhat for boys. It does almost every point kind of goes up. It does plateau near the very top. But we see the opposite relationship. We see a very clear negative relationship for girls. So as girls score higher in their reading ability, they have less interest, they have less motivation, less intentions to study math going forward. And because there's a correlation between doing really well in reading and doing really well in math, this may explain why girls and women, why there's a gender gap in when they measure how these genders on average value math. And this is a graph that it's kind of a statistical trick where it's basically this information corrected for, accounting for this relationship in reading. And when we do that, we see very, very similar relationship between the math ability and the intention to study math going forward. When you account for that, you see that boys and girls really, they don't statistically differ in their value and intentions of studying math going forward. Whereas if you look over here, the boys are well above the girls. So you might conclude that there's something about girls, they just don't like math as much. Well, actually, that may not be the case, because when you account for reading, they seem to like math just as much and value it and have the intentions to pursue it. And so the hypothesis is that because girls tend to be even that much more, that their ability in reading is that much more and tracks above, it outstrips their ability in math, that these individuals at the high percentiles of math are even more, their ability is even greater in reading, and this might be outstripping that value and intention of mathematics. And so it really doesn't have anything to do with, it might not have anything to do with the ability girls' and women's ability to mathematical ability, but instead has to do with their greater abilities in reading and language. And so a very interesting hypothesis, fairly new. This is just a paper from last year suggesting this based on this observational data. But also important to note that, like almost all of biology, there's almost never ever a single factor that explains all the variation that you see in the system. This is especially true when you're looking at populations, or even when you're studying the organism, an individual. There's lots of factors that explain phenomena that we see. And certainly there's plenty of evidence to suggest that at least some of the discrepancy that we see in gender-based biases and things like hiring and the pay gap are not fully explained by things like this, but certainly in part they are, and could be. So that's the end. Feel free to come back to class on Friday with any questions that you have about this specifically. Thank you.